Hey, St. Mary Grade 8s, Mr. McHenry back with another math lesson. Today we're going to be talking about number, properties, and variables. So we've been using variables and solving for them. And some of you are asking, well, why do I need to understand how to solve for variables? Well, many of you will use them throughout your lifetime to solve different things in your job. For example, scientists or engineers, doctors, nurses, among many people, also people that are in business and whatnot, all have variables that they use to solve in terms of finding out how much something costs, etc. So we need to know about variables. So today we're going to talk about some number properties and variables. And as we know, variables is a letter or a symbol representing quantity that can vary or change. And we often use an italicized letter such as X, or we could use another one. Today we're going to use N. Okay, because N is sometimes used because of the fact that the word number starts with N, so we're going to use N. So when we use a variable to represent a quantity or number, these properties for numbers also apply to variables. So we're going to start off by saying let N represent a number. So adding 0. So adding 0 does not change the number. So for example, if we had 4 plus 0, that is going to equal 4. And therefore, if we have N plus 0, so a variable plus 0, that is going to equal the variable. In this case, it's N. And what if we switch that around? If we had 0 plus 135, well, that's going to equal 135. And if we had 0 plus N, or a variable, well, that is still going to equal the variable. So adding 0 does not change the number or the variable. The next one we're going to talk about is multiplying by 0. When 0 is a factor, or you're multiplying by 0, the product or the answer is always 0. So if we have 4 times 0, well, that equals 0. And therefore, if we had N times 0, or a variable times 0, that is also going to equal 0. If we had 0 times, I'm going to write it this way, times 135, well, that is going to equal 0. And if we had 0n, so that's not on, that's n with a variable, and there's an itty bitty times right in there, that is also going to equal 0. All right, so when 0 is a factor, we're multiplying by 0, the product or the answer is always 0. Multiplying by 1. When 1 is a factor, we're multiplying by 1. The product is always the other factor, the number that we're multiplying by. So, for example, if we had 1 times 4, okay, that is going to equal 4. And therefore, if we had 1 times N, that is going to equal the variable. Okay? If we had 135 times 1, that is going to equal 135. And if we had N times 1, that is also going to equal N. Okay. The last one that we're going to talk about for a second is the order of addition and multiplication. So when you add, the order does not matter. So we can have 4 plus 9 is equal to 13, Or we could have 9 plus 4 is equal to 13. Okay? And similarly, we can have A plus B is equal to A plus B, or we could have B plus A is also equal to A plus B. Okay, another example is we could have 135 plus 5 is equal to 140, or we could have 5 plus 135 is equal to 140. And we could have B plus A is equal to B plus A, or we could have A plus B is equal to B plus A. All right, so the order does not matter when we add. Similarly, when we multiply, the order does not matter. We could have 4 times 6 is equal to 24, or we can have 6 times 4 is equal to 24. And we could have A times B is equal to, and I'm going to write it like this, AB, so there's a little multiplication sign in there, or we could have B times A is equal to AB. Okay, another one, we could have 135 times 2 is equal to 270, or we could have 2 times 135 is equal to 270. Similarly, we could have B times A is equal to AB, or we could have A times B is equal to BA. All right, so some properties that apply to both numbers and variables. Now, one thing that we want to talk about, because we're going to need to know about it, is adding like terms. Okay, and like terms means that they are the same. So we all know that we are able to add 7 plus 11. And why are we able to add 7 plus 11? Because both 7 and 11, okay, are 7 and 11 are numbers. So we can add them, and we know that that equals 18. Okay? Now this next one here, we have 7 plus 4b. Well, these are not alike. We have 7, which is a number, and we have 4b, which contains a variable. So they're not like terms. So we can't add. All right, so we just have to leave that as it is. The next one, we have 7a plus 4b. Well, 7a is a variable, and 4b, even though it's a variable, it's a different variable. So again, these are not like terms. They are apples and oranges. So we cannot, so it's not like terms, can't add. Okay, our next example, we have 7c plus 4c. Well, 7c is a variable, and 4c is the same variable. So we have like terms. So we can add. So in this case, when we add them, we add the numbers, and it is 11, and we put the variable c. Okay, what about this last one here for big expressions? We are able to add like terms. So we're able to add numbers and variables that are the same. So do I have any numbers and variables that are the same? Whoop, I have some numbers with no variables. So I can add these numbers. So that equals 11. Do I have any other numbers with an A on it? No, I don't. So I cannot add anything to 7A. Do I have anything with a variable b on it? No, I don't. So I cannot add anything to 4b. Do I have anything with c on it? Yes, I do. I have 7c and I have 4c. So I can add these two terms because they are like terms, and that is equal to 11c. Okay? But I cannot add anything further because now I have not like terms. Can't add further. Okay, so that's something to keep in mind as we move forward with our math, is about adding like terms, and for sure you will be learning about this next year in high school about like terms. And the reason why we covered that was we need to know about that for the distributive property. Okay, you may recall that A and then bracket B plus C means, well, what does this mean here? That means there's an itty bitty times sign, and we show that there, okay? That's a times right here, multiply. And we know that AB, and there's an itty bitty times in here, so that means A times B. And AC means that there's an itty bitty times in there, so that means A times C. So we want to talk about the distributive property. And the distributive property is that we have A times bracket B plus C is equal to A times B plus A times C. Okay, so the product of A bracket B plus C is the same as the sum of A times B plus A times C. And we are going to show that through a proof. Now, in your math career, you're going to have to show things work by examples, and we call that doing a proof. So the proof of distributive property. So we have here what we stated, A times bracket B plus C bracket equals A times B plus A times C. And we have some rows and columns here, and we're going to use these numbers in the rows and columns to prove the distributive property. So the first one that I'm going to use is for row 1 here, and I'm going to use the numbers in row 1 in column A, B, and C. So I have on the one side A times bracket B plus C bracket. So what am I going to do? I'm going to substitute. I'm going to substitute A is equal to 2, B is equal to 4, and C is equal to 7. So if I substitute that into A bracket times bracket B plus C bracket, I get 2 bracket 4 plus 7. Okay? And I'm going to use my BEDMAS rules, and my BEDMAS rules say that I have to do what's in brackets first, so I do what's in brackets first, and I get 2 times 4 plus 7 is 11, and now I multiply this together and I get 22. Well, let's see what happens on this side. Again, I'm going to substitute A is equal to 2, B is equal to 4, and C is equal to 7. And I substitute it in, so I have 2 times 4 plus 2 times 7. Okay, and I'm going to simplify. 2 times 4 is 8, plus 2 times 7 is 14. And 8 plus 14 is 22. So therefore, 22 is equal to 22. Therefore, A times bracket B plus C is equal to AB plus AC. Okay, so we just don't try it once and see if it works. We have to try it another time, and we're just going to try it one more time. Actually, 2 more times. So here I have my numbers from the column, and I'm going to substitute them in. So I have here 3 times 6 plus 2. Okay, I use my BEDMAS rule, so it's going to be 6 plus 2 is 8. 3 times 8 is 24. On this side, I substitute in, so I'm going to have 3 times 6 plus 3 times 2. Okay, simplifying is 18. 3 times 6 is 18, plus 3 times 2 is 6, and I get 24 again. So therefore 24 is equal to 24. Therefore A bracket B plus C is equal to AB plus AC. All right, last one here for our proof. Okay, do it 3 times, and that's good to move forward that what we think is true. So again, we're going to substitute in. So I have here 0 bracket 7 plus 2. 0, I do BEDMAS, 9, and 0 times 9 is equal to 0. Okay, on this side, I have 0 times 7 plus 0 times 2, and 0 times 7 is 0, plus 0 times 2 is 0, and I get 0 again. So now I have, therefore, 0 is equal to 0. Therefore, A bracket B plus C, or A times bracket B plus C, is equal to A times B plus A times C. Okay, so what is the big idea here? Well, the big idea is, and this is the most important part, is that when we use the distributive property, we expand by multiplying into the brackets. All right, so we have this here, A times B plus C, and using my BEDMAS rules, I would normally add what's in the brackets, but I cannot add what's in the brackets because B is one variable and C is another variable, a different variable, and therefore they're not like terms, so I'm not able to add. But I know that A bracket B plus C is equal to AB plus AC. All right, and which is like we are expanding an expanded A bracket B plus C bracket by, so we take A, rewrite this again, we take this A and we multiply it by the B. We take the A again and we multiply it by the C. All right, and so we've taken the A and we're multiplying into the bracket, and we multiply it by the B, and what do we get? We get A times B. And then we take the A and we multiply into the bracket again, and we times it by the C. So we have A times C. Or we can change that to be equal to AB with that itty bitty multiplication in there plus AC with the itty bitty multiplication in there. Okay, and then we're adding AB plus AC. So when we use the distributive property, we expand by multiplying into the brackets. Okay, we've used a lot of letters here. Let's use some numbers with some examples. Our first example is 7 times bracket C plus 2. So the first thing I do is I look into the bracket, but I cannot add in the bracket using my BEDMAS rules because I do not have like terms. I have a variable and I have a number, and I cannot add a variable and a number together. So, but I know I can use the distributive property and expand the expression by multiplying into the brackets. So I can take this 7c plus 2 and I'm going to multiply into the bracket. So I'm going to take the 7 and multiply into the bracket to times the c. Okay, so the first one is going to be equals 7 times c. Then I'm going to put the plus sign down here. Then I'm going to take the 7 and I'm going to multiply into the brackets again and times it by the 2. So I have 7 times 2. Okay, I'm just going to, or some of you will write it as 7c, or it will be shown in your book, textbook, or in questions, or 7 times 2. And where we can, we want to simplify as possible. Is it possible to simplify here? Yes, it is. Nothing here. 7c stays the same. But I can simplify. 7 times 2 is 14. Okay, I look at this and say, can I do anything more with it? Can I add these terms? No, I can't add these terms because they're not like terms. So that is the answer for writing each expression as the sum of terms using the distributive property. Okay, another example. We're going to do the same thing. We're going to use the distributive property to write the expression as a sum of terms or an addition of terms. So I look at this expression and I see the brackets right away. I remember my BEDMAS rules. Can I do anything within the brackets? I have 2a. Any more a's in here? No. I have a b as a variable. Any other b's? No. And I have a number. Any other numbers without any variables attached to them? No. So I have not like terms here. So I cannot add within the brackets. But I can use the distributive property and expand the expression by multiplying into the brackets. So I'm going to rewrite the expression here again. And I take the 2 and I multiply into the brackets. This is my first one here. And that is equal to 2 times 2a. And bring the plus sign down here. And I multiply into the second term into the bracket. And this time I have 2 times 3b. And do I have any other terms in the bracket? Yes, I do. I have a third term. So I'm going to multiply the 2 times the 4. And I have 2, so I bring the plus down. And I have 2 times 4. Okay? Some of you might write it a little, or we can write it as 2 times 2a plus 2 times 3b with the brackets plus 2 times 4. Okay, now I want to simplify if possible. Now this is important. I am able to simplify this. We are obviously able to simplify the 2 times 4 here. We know that that is going to equal 8. However, we are also able to multiply the 2 times 2a and the 2 times the 3b, even though they are not the same or they're not like terms, because we can multiply not like terms together. So 2 times 2a is equal to 2 times 2 is 4, and we attach the variable to it, plus 2 times 3 is 6, and we attach the variable to it because there's an itty bitty times in here. Because if we were actually to do this, what this would look like would actually be, because there's an itty bitty times here, this would actually look like 2 times 2 times a. And that goes into 2 times 2 is 4, and then times a is 4a. This one would actually look like, because there's a little itty bitty times between the 3 and the b, 2 times 3 times b. Well, 2 times 3 is 6, times b is equal to 6b. And that's why we are able to multiply not like terms. Okay, so we're simplifying that, and now we look at this. I'm just going to rewrite it. So we have 4a plus 6b plus 8. And I look at this. Can I simplify it any further? Can I add any of these? No, I can't, because they are not like terms. I have an a here, I have a b here, and I just have a number here. So that is the answer to this expression. All right. So please practice these distributive property questions, and that will be provided on the D2L. Take care.